Okay, we're now concluding with our CMMT ST Modulo mode, uh, but we'll be using the add-on instruction in Studio 5000, and I've got version 32, so I'll send this out and you can open it up in version 32. So the first thing is, and there is a application note on how to do these basic setups, but I'll go over it real quick with you. You want to install the EDS file, which has been provided to you. And when you install it, you want to double click on it. Give it a name. I named this chip door underscore servo. I was doing a free-to-lay application, so I'm just keeping it the same. Set the IP address to the same IP address we set in Festo Automation Suite for the Ethernet IP. The next thing you want to do is click change. Make sure you don't skip this part. It's very important. So make sure you click change here. And then these are in cents, but you want to change these into integers, 12 and 12 input and output integers. Click OK. And you should be done with that. And just make sure. And the next thing you want to do is import your add-on instructions, which is was given to you also in a link. The only one you need is this point-to-point PTP drives, Festo Ethernet IP. So bring that in. Then you're going to create your program. Drag this over and insert it to a line. There are some comments that I like to put in right above it under the edit line. And these can be found in the application note too. So I copy them out of the application note and then paste them here. There are different modes we can run this in. If we put a 1, so this mode position right here, I got a 2 in it now, and that means I can make moves in absolute position. Put a 1 there, I can make moves in relative position. But for this demo, we're only going to be using 2 for moving in absolute position, and we're going to use 6, the record select table, which we just went over in Festo Automation Suite. And we're going to call record 1 to home it, to set the modulo mode, and to offset it by 10 degrees. So when you get the add-on instructions installed, the point-to-point, you got to give it a name. Here, the tag name. So I always name it the same thing as you name the servo drive here. So I did a chip door servo. So, and I named it chip door servo's exact same name. Then you want to point to your inputs and output integers. So basically, they will be created for you. And you should see this chip door underscore servo input data 12 integers. And the same thing here for your outputs, drive control here. So just locate them in your tags here. And you want the servo output data integer 12. Okay. And the only other thing you really want to set is configure EPOS. I want you to put a 3 in here. Okay. And the base speed, I think you saw in the Festo Automation Suite, I had the base speed at 500. So we're going to put 500 there. So they're the same. So we get that correlation of readings. Below here, the monitor area is going to be the actual position we'll be in and the actual velocities. There are some other things here. The enable axis will kick in and enable the motor, cancel transversing. So for this thing to operate, we need a 1 on enable axis, a 1 on cancel transversing, which is just a stop command, and a 1 on intermediate here. So that is a pause command. So if it goes to 0, it stops it and pauses it. And then when you bring it back to 1, it continues. So we want to keep these 1s and put a 1 on the positive here. This is going to make sure it goes in one direction only. when we rotate in the positive direction. And then we have our jog 1 and 2, negative. So to do jog, we'd have to use number 7. We'd have to put a 7 in here to jog it, like that. And then we could, if we turn this to a 1, it would jog positive. And then you to stop it from jogging, you have to put it into 0. And same thing for jog 2, but that's the negative position there. So that's the basics there. Let's connect to it. I do have some code here, some simple code written here we'll go over. But jog, there's acknowledge error. We put a 1 to acknowledge the error here, and then you have to toggle the enable to get it to go away. And you'll see I'll create an error real quick. And then we can write positions to the position table, velocity here. And over velocity and over accel and over decel correlate to what was in the Festo automation suite, and that says to run it at 100%. So if you want some half speeds of acceleration or decel, you can set it to 50. The over velocity is actually if I kept this at 100. Now this is 100 degrees per second here because of the -2 I had you put. So if I put 50 here, it would go at 50 degrees per second. In the position here, it's a 1 and 3 zeros, so that would be 10 degrees. So it would be a 10.00. So that was that -2 that I showed you in Festo Automation Suite. And let's get it working. So we're going to communicate, go online. Let's see, I didn't make any changes. Okay, so we're online. We see that we have an error. We're locked out. This is because of the factory automation suite. When we lock it out every time we enable it with the factory automation suite. So what we have to do is enable it, topically enable. So just to show you how to clear out an error, this is acknowledge error here. So I change that to a 1. I toggle the enable. So I set it to a 0. And I set it back to a 1 to toggle it reads on a low to high transition. The motor kicks in and wait a few seconds. And then you will see the outputs light up. The axis is enabled. Axis position is okay. We are at a axis is at a set point fixed position. So those 3 lights, so we are enabled, but you notice that we don't have a axis reference. That means there's no homing done. So we have not homed it. So to home it, we are going to call up that record table that I showed you. And what we're going to do is put a 6, which I have a 6 here already. Okay. So this is call up the record table. And we have to name what record we want to put. And you have to put a 1 in position. So when we go to number 6, we're actually calling up the records, 1, 2, 3, and 4. But we're going to call up record 1 there. And to do that, I wrote a little new positioning here. So let me just show you that if I put a 2 there, new position, it then transfers this. It's a move operation. I transferred it to, I got to get rid of that acknowledge error first. I got to change it to a 0. And that got changed now with positions 2, but we want position 1. I have a little code in here, so I had to turn off the fault acknowledge. So I'll change this to a 1. And we got a 1 here. We have to execute or start the task, and it needs a a toggle here, so I need to go from 0 to 1. So it's looking for a 0 to 1 transition. So I change it to 0, and I change it to 1. And now you can see that we have the green on the axis reference. It went to our record table and did the sequence, and the actual value is 10 degrees right now. So we did use the record table to home it, set modulo, and then bump it off 10 degrees. So everything worked as planned. Now we can write positions like I showed you. We will change this mode position from a 6 to a 2 to its absolute position. We put a 2 here. Okay. Now I can go to my move command for position, and then I can write 100 degrees, 1, 0, 0, 0. And velocity, I'll do 250 degrees per second. So, and we can look up here. I do have that to move to 100 degrees and a velocity of 250 degrees per second. Again, I need to toggle the execute command, change it to 0, and then change it to execute to 1, reads from a 0 to 1 transition. And we look here, and it looks like I still got the position at 10. So I did not put 100. Let's try this again. 100. Okay. No, I'm sorry. I did go to 100. So I am at 100.07. I can check that in Factory Automation Suite too. I can't be connected while the servo is running under Ethernet IP. And I can see that I'm at 100 degrees here also. So you can view it while connected, and you can have the control by the Studio 5000. So I did 100, and like I said, I can then do the other 90 degree, which would be 190 degrees. Okay. I have a start task here, so I'll just start it from here. I'll toggle a bit here, toggle there, and you'll see that I'm at a 190 now, 190.07. I did write a little program here to check the position and set tolerance. So what I'm doing is plus or minus 0.5 degrees. So I put 50 in here for tolerance. So it says take the actual position, add the 50 to 0.5 degrees, and then so I did an add and a subtract. I took the 190 degrees and subtracted 0.5. So I have a limit here that I need to be between 189.5 to 190.5, which I am, and it says I'm at the target position. So you can set that tolerance to wherever you want. So that's done, and then we'll just continue. Like I said, this works just like the record table. I'll put 280 degrees, and then I'll toggle it, toggle the bit, start bit, which is the execute bit. And now I'm at 280 degrees. I'm reading 280 degrees, and then we'll continue with that 10 degrees. So now I will put in the 10 degrees. That gets me back to the 12 o'clock position. 10 and 2 zeros. Toggle it. And I'm back to the 12 o'clock position, and I'm reading 10 degrees. Okay, we can look at the Factory Automation Suite. We can see the modulo mode is at 10 degrees, but the actual encoder, if we didn't have modulo mode, it would continue, and I'm at 370 there. So, but we're looking at modulo. So, if there's any questions, I'll send you an email, and you guys can email me back, but I think this should help you get started. Take care.